Section 2, still on the topic motion. In this section, we'll be looking at equations of uniformly accelerated motion. A uniformly accelerated body undergoing a linear motion can be expressed with the following equations. 1. Equation 1, V equal to U plus AT. Equation 2, V squared equal to U squared plus 2AS. Equation 3, S equal to UT plus half AT squared. Equation 4, S equal to UT minus half AT squared. Equation 5, S equal to V plus U over 2 times T, where V is equal to final velocity or speed, U is equal to initial velocity or speed, A is equal to linear acceleration, S is equal to distance or displacement, and T is equal to time. Notice that there are 5 different parameters in the equations. Whenever you are given a problem of uniformly accelerated linear motion, the question will lack one of the parameters, while you'll be asked to find one. So, in questions involving uniformly accelerated motions, one of these 5 parameters may be missing, in which you'll be asked to find one of them. Notice also that equations 3 and 4 contain the same parameters, the difference being while equation 3 has a positive sign in it, equation 4 has a negative sign. You can observe what is going on here. This is UT plus and this is UT minus. Equation 4 is used only for bodies acting against gravity. That is when a body moves up a height. So equation 3 and 4 are the same, just that the sign is different. For equation 3 is positive and equation 4 is negative. And so we say that you use equation 4 when the bodies are acting against gravity. That is when they are moving up a height. When objects are moving up a height, you use equation 4. Example 1. A car accelerates uniformly from rest at 3 meters per second square. Its velocity after traveling a distance of 24 meters is, we have options: A, 144 meters per second, B, 72 meters per second, C, 36 meters per second, and D, 12 meters per second. So we saw from the question you were given initial velocity U to be equal to 0, because at rest the car have not started moving. So because they said the car was at rest, that means the initial velocity is 0. Acceleration A is equal to 3 meters per second square, and the distance traveled 24 meters. And we are asked to find the final velocity V. The equation to be used is equation 2, as it contains 3 of the parameters given. Therefore, we use the formula V squared equal to U squared plus 2AS. V squared is equal to 0 squared plus 2 times 3 meters per second square times 24 meters. Therefore, we have V squared equal to 0 plus 6 meters per second square times 24 meters. V squared is equal to 144 meters squared per second squared. So V is equal to square root of 144. I will have V to be equal to 12 meters per second square. So the correct option here is D. The correct option is D. 12 meters per second. 12 meters per second. Example 2. A car starts from rest and moves with a uniform acceleration of 30 meters per second. 30 meters per second square, acceleration of 30 meters per second square for 20 seconds. Calculate the distance covered at the end of the motion? Option A, 6 km. Option B, 12 km. C, 18 km. And D, 24 km. Solution. The parameters given here are initial velocity u to be equal to 0 because the car started from rest, acceleration a equal to 30 meters per second square, and time t equal to 20 seconds. And we are asked to find the distance travelled s. Therefore, the equation to be used is equation 3, and it is s equal to ut plus half at squared. So s is equal to 0 times 20 plus 1 over 2 times 30 meters per second square times 20 second squared. S is equal to 0 plus 1 over 2 times 30 meters per second square times 400 seconds. S therefore is equal to 15 meters per second square times 400 squared seconds. This is s squared seconds. So we have s to be equal to 15 meters per second square times 400 s squared seconds squared. Therefore, s is equal to 6,000 meters. 15 times 400 is equal to 6,000. So s is equal to 6,000 meters. From the options, the answer is in kilometer. Therefore, we need to convert the meters to kilometer. Converting 6,000 meters to kilometer, we have that 1 kilometer is equal to 1,000 meters. Therefore, 6,000 meters is equal to 6 kilometers. So the correct option here is option A, 6 kilometers. Example 3. A car moves with an initial velocity of 25 meters per second and reaches a velocity of 45 meters per second in 10 seconds. What is the acceleration of the car? Option A, 5 meters per second square. B, 25 meters per second square. C, 20 meters per second square. And D, 2 meters per second square. Solution. Here we are given initial velocity to be equal to 25 meters per second. Final velocity 45 meters per second. And then time 10 seconds. And we are asked to find acceleration A. Using equation 1, we have v equal to u plus at. First of all, we'll make acceleration the subject of the formula. The equation becomes a equal to v minus u over t. So when you make a the subject of the formula, you have a equal to v minus u over t. So a is equal to 45 meters per second minus 25 meters per second all over 10 seconds. A is equal to 20 meters per second over 10 seconds, and we have a to be equal to 2 meters per second. This is 2 meters per second square. So the correct option is D, 2 meters per second square. And with that, we come to the end of this section.